Hi, welcome to my video on the chain rule, more examples, and this is number 4. And again, more examples help you understand the derivative of functions which are comprised of composite functions. Find y prime. Again, y prime is d dx on each, but I'll just do that for, so d dx on the y and d dx on 2x plus 1 and 3x plus 1 squared. So d dx, just to explain, d dx on the y is the same as dy dy dx on the y. So notice we have dy, we got dy dx. I should have reversed those, and dy, put the y here like that. So dy on the y is 1. So dy dx becomes 1 times dy dx is dy over dx. So automatically, when it looks like we can go from here and put dy dx just like that, put the y with the d, but there's the mechanism for working it. Y becomes dy dx. Now we do the derivative of this in terms of x, because all x is here, so d dx. So this is f and g, and so if that's f and g, so that's f times g derivative. That's the product rule, so it's derivative of f times g plus f times the derivative of g. So that's, we have, make sure I got enough room here now. So there's 2x derivative of f times g plus 2x, which is f, times the derivative of g. So we got to put this bracket around that derivative. So there's the derivative of f times g, and there's f times the derivative of g. So derivative. So dy dx, which is, again, y prime. So y prime is dy dx. So we do the derivative of 2x plus 1, which is 2. And this is 3x plus 1 squared. And we got 2x plus 1. And the derivative here, again, you can see that this derivative, now I'm going to take a shortcut here. This is the derivative of a composite. So it's the derivative of this whole function, which is 2 times 3x plus 1, because the power of 2 goes in front, and that decreases by 1, times the derivative of the inside. The derivative of 3x plus 1 is 3. So I took a little tiny shortcut there. I didn't show you, I didn't do 3x plus 1 squared derivative times 3x plus 1 derivative. So I do the square first and then the inside after. So dy dx, which is y prime, that gives us. Now, let's simplify all this. So it's 2, 3x plus 1 squared. So I have a 6, 2x plus 1 times 3x plus 1. So to simplify this, we have to square this. So we can square that by doing, you square a binomial. We square the first term, which is 9x squared. We square the last term, which is 1, and we multiply these two, 3x by 1, and double it. 3x times 2 is 6x, so that's how you square it fast. So I got the squaring done. So let's do the multiplication of the two binomials here by FOIL. 2x times 3x is 6x. Outside is 2x. Inside is 3x. 1 times 1 is 1. So we simplify the inside, just makes it easier. If you simplify your brackets, it makes it easier when you do your math. So 6x squared plus 5x plus 1. Now we have the inside simplified. So we multiply, we get 18x squared plus 12x plus 2. And we get 36x squared plus 30x plus 6. Add up the like terms. 36 and 18 is 54x squared. 12 and 30 is 42x. 2 and 6 makes 8. So that's the derivative. Again, is the product rule under one composite function inside of that. Now let's try another one, dy dx. This is y prime. Again, that's dy dx. So let's just go right straight to y prime. But again, we have a composite function. We have the f of x is equal to e to the x, and the g of x is 2x ln x cubed. So there's two functions, so we got two derivatives twice. So we do the derivative of the main function, which is this, times the derivative of the inside, which is 2x ln x cubed. There it is, derivative. So e to 2x ln x cubed and derivative of the inside. So that gives us, now this is a composite, this is a product here. So without doing the, let's delay the derivative. We'll do all the derivatives in the last step. Now this is a product. So this is f and the g. And when we do the derivative of a composite, we get f prime g plus f g prime. That's the derivative. So we have, okay, here we go. There's 2x derivative of f times g. Add on f, which is 2x, times the derivative of g. And again, there's a big bracket and a big bracket because this function here is multiplied by the product rule, which has a plus in. So this is this bracket right here with a plus. Now let's do my derivatives here. And we have the main function and the derivative. So this is okay. We expanded this. So y prime, the derivative here is e to the 2x ln x cubed, and that's what we have. Anything e to the 2x, anything to the e power is itself. And so let's continue. So now we have 2x, derivative of 2x is 2 ln x cubed plus 2x, and the derivative of, this is a composite function here. So really, I got to go the derivative of ln of 3x, so that's 1 over, the ln of x cubed, is 1 over x cubed times the derivative of the inside, which is, the derivative of x cubed is 3x squared, because it's a composite function here. This is a composite made up of ln x and x cubed. So we have, I took a shortcut here. I could have wrote it out, but I just did the derivative of the ln of x cubed. There it is. So y prime is e to the 2x ln x cubed, and we have 2 ln x cubed, and we have to simplify here. So we have, that cancels, sx and x squared. That's an x cubed, so they all cancel out. So that gives me a plus 6. And we got what I see here. I see a 2 here. If I want to factor this or leave it like this, I can take the 2 out of here, put it right here in front. And I took the 2 out, so 2 divided by 2 is 1, so it's ln x cubed. 6 divided by 2 is 3, because this is factorable, but that's the answer. But if you want to write it in factored form, then there's a better answer in factored form, if you wish. And again, we have a derivative of a composite function, which gives you the chain rule. And again, if you enjoy my video, click on the like button, click on the subscribe button, visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content of my YouTube channel called Math Fully Explained. Just one word. Thank you for viewing my video. Hope the video helped you. Bye-bye.